As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-thru or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk. I'm your host, Neil Degrasse Tyson, your personal astrophysicist. And I got with me Chuck Nice. Chuck!
Yes.
Chuck in the house.
Neil.
All right. This is a Cosmic Queries edition.
Absolutely.
And we're celebrating 30 years of the Hubble Space Telescope.
Wow.
Yeah, 30. It was launched in 1990, April.
Look at that.
Yeah. And we're talking across someone right here.
I know.
who's
So
got some
rude of us.
So rude.
Very rude of us. Edwin would be ashamed.
So we have Jennifer Wiseman. Jennifer, welcome.
Thank you.
I think yours your first time visiting
It's
here.
wonderful to be.
You know, we go way back, but your first time. So it's long overdue. And I got your pedigree here. Senior project scientist for the Hubble Space Telescope at the NASA Goddard. What's the full Goddard?
Space Flight Center.
Goddard's because we have a Goddard here.
We have
That's
a
why
Goddard
it's coming up.
Institute for
Exactly.
Space Studies.
Yeah, we have a
here.
Goddard Institute for Space. Goddard got around.
Goddard,
He had
yeah.
a rocket, so he
Yeah.
got around. So the Goddard Space Flight Center in Greenbelt, Maryland.
Correct.
Right outside of Washington, D.C. And you're primarily responsible for making sure Hubble is as scientifically productive as possible.
Wow.
And sure enough, that's what it has been. We're going to get into that.
Yeah, there's a lot of good
And you're
stuff.
professionally, what would you say is your cosmic specialty?
I'm interested in how stars continue to form in interstellar clouds. So,
So all those pictures from Hubble with the
Right.
stuff with the clouds,
Yes.
that's her.
Nice.
well, that's not all.
She took them personally.
Not exactly.
She owns them all.
Yeah, she owns all those pictures.
This is called inflation in some way. No, there are people all over the world studying different aspects of how stars and planetary systems around them, presumably, are continuing to form.
So,
cool.
but it's you're in the right place to be fed.
Absolutely.
Continually.
We're just we're blessed to be fed with all this new information from the Hubble Space Telescope and also telescopes, all kinds of other telescopes in space and on the ground. We use them all together in complementary fashion.
So as you kind of layer the information to put it together and get a dare I say it, a better picture.
Exactly. I think of it like a symphony orchestra. The conductor is pulling out some parts of the music from the trumpets and some from the percussion and some from the violins and so forth. But all together, it gives you the full piece of music. So astronomers use some information from the Hubble Space Telescope, some from other space telescopes, some from telescopes on the ground. They all have some different niche. You know, they get some different colors or parts of the wavelength spectrum or a different types of fields of view and precision. And we use all that together to answer the questions we have about galaxies or stars or planets or whatever we're interested in.
So tell me, you don't just happen to be at the Goddard Space Flight Center. That's where Hubble is controlled.
The Hubble Space Telescope control room is, yes, at the NASA Goddard Space Flight Center.
Then what's that Hubble building on the campus of Johns Hopkins?
At Johns Hopkins, we have the Space Telescope Science Institute, which is a wonderful place with hundreds of scientists and other specialists who work with us at Goddard to help us manage the daily science operations of Hubble, to help with the selections of which proposals that are sent in from around the world actually get the time on the Hubble telescope.
I don't think people think much about that. The data just show up.
Right.
But somebody had
to do an American Idol version of, yo, I need Hubble. That's the next big show coming to Fox.
Yes,
Yo, I need Hubble.
Show me your proposal, right?
That's a really good analogy, but it's not done quite the way it's done in terms of the TV shows. What's done is that scientists around the world will write a written proposal for why they want to use the Hubble Space Telescope. Why are the observations they want to do so important to advance science? And why do they need the Hubble Space Telescope to do that?
Okay.
As opposed to any other telescope
Exactly.
that they could be applying for time on.
Right.
Because you don't want to waste. I think this is true for the allocation committee. They're not going to give you time for a proposal that you could do on a ground-based telescope. Okay. Because space-based telescopes are so expensive and so precious every moment of observing time. Right?
Exactly.
Yeah.
So you have to make the case. Why is it important that we use this precious time with the Hubble telescope to observe this particular galaxy or this particular exoplanetary system? And why do we need the Hubble telescope or the particular instruments that are on Hubble to do that? And that goes through a pretty stringent peer review process. We have specialists come in and review all the proposals and rank them. And in the end, basically 1 in 4 or 1 in 5 get time on the Hubble Space Telescope.
What's it like on American Idol? Is it 1 in 5?
I think a little bit less than that.
So you're better off applying for Hubble time than winning American Idol.
Actually, it's you probably are, but probably not, to be honest.
Although I should add that we're pretty good about storing this data. So once the observations are done with Hubble, the data are put in an archive that's easily accessible. And so scientists around the world often go into that archive, pull out data that's already there, but they can use it for something else. And in fact, about half of the results, the peer-reviewed, published science discoveries and results coming from Hubble now are based on data that scientists have taken out of that archive.
So if you use the telescope, then everything that you glean from using it is now open source.
No, it's better than that, I think.
Is it better?
No, because I had my own motives for observing that part of the sky.
Right.
Yeah.
But maybe you have another thing you could extract from the data that I haven't thought of yet.
Right.
That's
right.
Exactly. That's right. So
but there is nothing proprietary.
Well, there is.
There is.
For some types of
Now I'm
observations.
interested in that. See, now that's all I care about is who gets the proprietary stuff.
There are some types of proposals where the proposing team get a few months.
Jennifer's got to find, this is my cluster.
Right,
This
exactly.
No, nobody owns anything in the universe personally, but
Not yet, but go on.
Some of the proposals, the proposing team gets a few months of time to do what they actually propose to do and do it well, because we want them to have the time to do it well. Okay. And then the data gets put in this archive, and then it's open to everyone. And there are other types of observations that are generally done, like big surveys and things that let's say the director of the Space Telescope Science Institute decides would be a good general purpose use of Hubble, and that data immediately goes into public purview. So it can be immediately used by scientists around the world, but anybody in the public can reach the archive. We also have an image gallery that I think is probably of more interest to most general people in the science interested public, and that you can find at our websites, nasa.gov/Hubble or hubblesite.org. But these have the images, the things that you really think about when you think of Hubble's galaxies or
your desktop
nebulae.
screensaver.
Right,
Yeah, exactly. That's where you go, and that's just all free to anyone around the world to use and enjoy. And that's something I'm very proud of about the Hubble mission, is that we've made all of this data and all of these images free for anyone around the world to use.
That's why Shutterstock hates you.
Well, it's inspiring to everyone.
No, it is. And we thank you for it.
Before we get to the questions, I got one more inquiry here. So is it still true that the director can just say, here's a good idea. Everyone will benefit. Let's just do this. It's not going through the telescope allocation committee. Okay, so it's a director's discretionary time. Does that still exist?
It does. So the director of the Space Telescope Science Institute, who currently is Dr. Kenneth Sembach, has a certain allocation of time with Hubble each year that they can use for what they think is the most some scientific purpose that might not come through sort of the general competitive process with scientists around the world. And usually this time is used for, let's say, a kind of big survey or a general purpose observation that will be of use to people for many years to come.
Could it be used for something that's a little quirky? A little.
Well, let me tell you,
that would
a little quirky.
You would have to have a great deal of trust in that director You know.
Well, that's when you
I believe that there are aliens in NGC 3801. I'm positive.
All right.
Well, let me assure you that we take great care in choosing the directors of the Space Telescope Science Institute. We've had
Okay.
excellent ones.
I'm going to refrain.
And so I'll mention a couple of these that I think are particularly noteworthy.
They're not political appointees,
I
I
was
think
going
is
to
the
say,
point. Okay,
yeah,
right.
The current Institute, Space Telescope Science Institute director, Dr. Ken Simbach, has very wisely allocated director's discretionary time to do a lot of observations in the ultraviolet part of the spectrum, looking at stars and star-forming regions that radiate light in this high energy frequency range. Well, why is that? Well, that's because Hubble is really the only general purpose telescope right now that can see in the ultraviolet. And you have to be above the Earth's atmosphere to see in the ultraviolet because of the filtering effects of the atmosphere.
Unless you're Geordie LaForge.
Well, exactly. But this is important to get this data and get it in the archive while we can, and then we can use it for many years to come. There's another director's discretionary project that I think is really noteworthy, and this came from years ago. A previous director, Dr. Bob Williams, used his director's discretionary time to just point off in a direction of space where there weren't very many nearby stars to drown out the image, and just collected light for many
What, was
days.
he crazy?
Well, some
Pointing to
people-
nowhere?
Yes,
Exactly.
exactly. Listen, that's pretty dark over there.
Yeah, let's put the
Let's
telescope.
look there.
So,
There's
yeah.
nothing interesting there.
Some people did push back on this and said this is a very valuable time on this telescope. It's a lot of competition. Why would you, quote unquote, waste your director's discretionary time this way?
Because I'm director.
There you go.
But basically, it was, let's look and see. We think there are probably some faint galaxies that will pick up by just integrating light, receiving light for days, but we weren't sure. After several days of doing this, the result was this image that's now iconic. It contains thousands of little smudges of light. They are all galaxies. It's called the Hubble Deep Field, and we've done some subsequent ones called like the Ultra Deep
It's
Field.
one of the most famous images
It certainly
from Hubble.
is,
Yeah.
and
That's
it's
so
my
cool.
favorite. Yeah, but it really showed us visually what we may have suspected already just from the physics and the cosmological theories, but that our universe is filled with galaxies, and they come in many different shapes and sizes. And of
Colors
course,
and
the intriguing thing about getting these feels is that you're seeing all these galaxies in one picture, but of course, the ones that are actually farther away, you're seeing them as they were farther back in time. So if you can somehow tease out which of those galaxies are closer to us and which of them in that image are farther away, and compare their differences. Are they different in their morphology? Are they different in composition? Sometimes you need other telescopes to get that information.
Why does
But
this one look like a
Exactly.
sombrero?
Well, you can see how galaxies have changed over time. So it's a true time machine that you can now see visually. And Hubble really set the foundation for this kind of pictorial study of galaxy evolution. And I think it's just a wonderful accomplishment. But that was based on a very wise but brave use of director's discretionary time with the Hubble
great
Space
story.
Telescope.
with
love it.
naysayers all along.
Yeah.
And also, once the Hubble sort of pitches tent right there,
Right.
other telescopes can say, I can now get different kind of information from
By
that
going to the same
Let me
place.
go to the same place.
Exactly.
Wow.
Right.
So it's probably
Yeah.
one of the most observed spots on the sky today.
Certainly
amazing.
is. So
Right.
we now have we have other positions on the sky also that have been observed in these kind of deep field ways using different kinds of telescopes, like the Chandra X-ray Observatory, or
One of Neil's favorites.
telescopes on the ground. And all of these telescopes have different capabilities, and so they complement Hubble and are giving us a tremendous understanding of how the universe has changed over time.
Yeah, there you
Wow.
go.
That's really cool.
Yeah.
All right.
Very, very
Well, let's
cool
go to some.
stuff.
I don't know how much time we have in this segment.
I don't know how much time we have in this
A couple- we
segment
got time for a couple.
either.
Let's do it.
Okay. All right.
Patreon members first.
Yes, we do a Patreon member first.
Paying fans get their questions
Yes,
first. Yes,
because
okay.
They support us on Patreon. And
Yes.
quite frankly, we're easily bought. Thank you. This message brought to you by Chuck Nice from Star Talk Radio. Anyway, this is Sherry Lynn SK. She says, Dr. Tyson, Dr. Wiseman, and hey, Chuck.
That is not what she said. No.
That is.
No, okay.
Yes. And she goes, what are 2 or 3 discoveries that laypersons like myself can reference when talking to others about the fantastic contributions Hubble has given us? Right now, all I can say is it took some really pretty pictures of some stuff, and I need better ammo for those of us not literate in astrophysics.
Ooh,
That's
that
a
is a
lovely
great
question,
question.
right?
Yeah, rank the
Right?
science.
Way to
How
go,
would you
Sherry Lynn.
put that?
Well, I'm not going to rank order because there's a lot
Just
of
between
different
us
but
and our audience. No one else has to know.
But I would say there are some profound discoveries in different realms of astrophysics that Hubble has really made a groundbreaking, if you will, or space-breaking, if you will, a contribution.
I like the change there.
See what she did
I
there?
see what you
We
did.
saw what you did there.
Space breaking.
I think one of the first things Hubble did was to confirm that there are, in fact, supermassive black holes in the cores of galaxies. It was theorized that was the case, perhaps, but one of the first observations Hubble did was to look at the core of another galaxy. M87, for example, is one of these other galaxies that we knew was kind of active. We could see that there was like a high-speed jet coming out of the core, but we weren't sure what was causing these types of things. Hubble looked at another external galaxy and saw that the gas moving around the core of that galaxy was moving very fast. And so when you have something orbiting very fast, but you don't know what it's orbiting, you can pretty easily calculate what the mass of that material is based on the distance from the core that the material is moving and its velocity. And the only thing that could be that massive in such a small volume had to be a supermassive black hole.
Wow.
So Hubble then became what we call our supermassive black hole finder, because with subsequent instruments on Hubble, we actually looked at the cores of lots of other galaxies and confirmed over and over again that supermassive black holes are often, if not always, perhaps, in the cores of galaxies.
So what went implied but not stated there is you needed Hubble to do that because Hubble has very high resolution.
Exactly, right.
Other telescopes, it's just a smudge, and you can't find something so close to a tiny center.
Exactly.
Right.
Yeah, that's a point that needs to be made. The reason Hubble is there at all is because we put it above the atmosphere. The atmosphere has a blurring effect on light coming through, and it even filters out some types of light. So Hubble being above the atmosphere gives us very high resolution
Above it all.
observation.
Nice.
Exactly. And that's why we were able to use Hubble to discern this gas right around the cores of other galaxies. And on one side, it seemed to be moving away from us very fast. That would be the red shifted gas. And on the other side of the center of those galaxies, we'd see stuff that appeared to be moving toward us very fast, blue shifted light. And so you can tell that the material is orbiting very fast. And from that, calculate that the only thing that would create orbits that fast would be a lot of mass condensed in a very small volume. And the
there you
only
go.
thing that answers that question
Is
are
a black
supermassive
hole.
black holes.
So now let me ask you, as you talk about this process, what immediately comes to my mind is the process. How long does something like this take? Or is it that you are doing mathematical interpolation or making extrapolations from a period of time that you're looking at the information that you're receiving?
How long does what take? Just the whole,
The
whole
process,
discovery.
the discovery and observation and
Okay,
the whole
yeah.
deal.
Okay.
Yeah, good point. From proposal to published paper.
Right.
How long does that take?
Well, I have to say it all depends. So an observation, depending on what you're doing, like I mentioned, that deep field took several days of observations. Others, if it's something bright, if it's just one pointing, you can do it maybe in an hour or two.
Oh.
But then you need to go through some processing time for the data comes down, but it needs some data processing. In that case, usually we can get images out if they're just simple snapshots within a few days.
Wow.
But if you're doing scientific analysis, like you're doing a proposal to answer some question that requires quite a lot of analysis, maybe comparisons with data from other telescopes, these kinds of things, that can take months or a year,
okay.
sometimes even years. So it just depends on the complexity of the question that's being asked and that's being and the data, how the data are being used.
All right,
And then you
cool.
submit the paper, gets peer reviewed.
Okay.
Yes.
Then maybe they want adjustments to it because
Right.
you didn't dot your I or cross your T. Then you do that, satisfy the reviewer. Then it gets accepted for publication. Then it gets scheduled. right? And so that adds a chunk of time at the end there as well. But
See, and now I have we got to wrap it up, right? I know, but now I got another question, which is, and I'm sorry.
Which is, we don't have time for
Oh,
your,
come
for
on,
your
let me
damn
just ask.
question.
I got to ask it, man. I got to ask it real quick.
Put it out there.
Real quick. I got to ask. So, with that being said, considering the process, has anyone looked for something, right? And then peer review finds no, but then something even better was found from the information.
Well, sure.
Like found
Yeah.
from I can't call it a mistake. What do you call it?
You don't have time to answer your question.
Okay, all right.
We'll come back.
All right. Okay.
If you remember it after the break. Star Talk, Cosmic Queries, Hubble's 30th anniversary when we return.
Live with luxury. Live with power in the all-new Toyota Sienna Platinum. The all-new Toyota Sienna is an all-hybrid powertrain with upgraded style and available features like all-wheel drive, a second-row captain's chairs with ottoman, and a 1,500-watt capable power outlet. Live the Sienna life. Or live with style and live bolder in the all-new Toyota Sienna XSE. With upgraded interior and exterior styling and available features like 20-inch dark wheels, an HD entertainment center, and hands-free door and liftgate. Whichever you choose, live the Sienna life. Toyota. Let's go places.
Welcome back to Star Talk, Cosmic Queries, Hubble, 30th Anniversary Edition. We last left off with Chuck in the middle of a question. What happens if whatever issues a first proposed research paper confronts,
Right.
they discover something even better?
Right. Well, the peer review says, oh, no, that's not the case. And then they find something that's like, whoa.
Wait, the peer reviewers or the writers?
Both. Either one.
Anyway.
Anybody goes, wow.
But they missed something.
They missed something. And then they go, oh, my goodness. I just
Okay.
want to know if that ever happened. Like, I have a thing for that. So like radio keratotomy, like guy cut his eye and he goes, wait, I can see. Whoa, who knew? Like that. I love that.
Okay.
You know.
Mm-hmm.
Okay, let me try to parse that. So again, these observations typically go through 2 peer reviews. One is to get the time to use Hubble in the first place. So that means that they generally had a pretty good idea of why these observations would be useful.
Right.
And then there's the second one when after they've done the analysis of the data and they submit their analysis to the professional journal of what they think they found. And true enough, the journals can actually say, we don't actually think this is right or profound, and maybe choose not to publish it. But usually they do. What's interesting,
by then. Yeah,
but what's interesting is that data that may have been used for the initial proposers' purposes is now available for other researchers to use. And as we discussed about the archive, they can pull that data and find something that the original proposer didn't even think of to use with this data, and that has happened quite a lot. Let me tell you why.
It becomes a whole other research paper.
It becomes,
exactly.
And the reason is because Hubble has been around so long, 30 years now, of often taking sometimes repeated observations of the same areas in the sky for different purposes. We can now look back and see things that have changed over time, which is very interesting, in particular in our solar system. Looking back at images of, let's say, Jupiter over time, year after year after year, and then starting to compare these images and saying, whoa, as we look back at this data that maybe have been taken for different purposes in earlier years, but we can see trends. Let's say that big great red spot on Jupiter, it's a big storm, but as we look over the decades of
Chuck,
Hubble,
you know what its official term is?
No.
Jupiter's red spot.
Oh, there you go.
Exactly.
Right.
Just so you know. Just so you can stay with the lingo here.
I don't understand.
I don't want her to lose you.
Yeah, why you guys got to get all fancy?
I think we're trying to make it clear. The great red spot is there, but it is red.
It is a spot.
However, it is shrinking as we look at these images year after year after year. Like, whoa, this storm is changing. It's changing in color. It's getting smaller. We see new storms cropping up. So this is one of the benefits of having a telescope operating so long and being able to look back in that archive at data that may have been taken for some other purpose but then stringing it all together, and we see how things have changed, are changing over time.
Did you find the monolith in the red spot? She cannot authorize. Next question. Next question.
None detectable.
Oh, okay. Look
She's
at
not
that.
authorized to go beyond that.
Yeah, exactly. Now I'm seeing a conspiracy. All right. Robert Weaver from Patreon wants to know this. What is the most interesting, unexplained thing we have observed with Hubble? Is there something that astrophysicists are still trying to work out
Love
that
it.
Hubble has
Who asked that?
revealed?
Who asked that?
Robert Weaver.
Robert Weaver.
Way to go, Robert. You have impressed the room, sir.
Mm-hmm.
Robert, that's a terrific question, and a couple of things come to mind. Hubble is observing a lot of effects of what we call dark matter. And so we can't really see dark matter, and we don't know what it is. It's a mystery, but Hubble can see where it is because it's distributed pretty heavily in these clusters of galaxies. We can see the galaxies, but we know there's a lot more stuff in there because Hubble sees what's called lensing of light coming from behind those clusters of galaxies that's traveling through that cluster, and it gets distorted, it gets magnified and stretched out. And so background galaxies look kind of strange when they come through these regions. And we can, because of that, we can map out where the dark matter is, but it's still a mystery as to what it actually is. And even more mysterious is something we call dark energy, because this is a surprise. We were looking we've been, for all of Hubble's mission, we've been measuring very carefully the expansion rate of the universe. That was one of the original goals of Hubble. But just a few years ago...
Wasn't that one of the original reasons why it was named Hubble?
Well, exactly.
Because
so
Edwin Hubble himself discovered the expanding universe.
Exactly.
And so that if this telescope was going to go all in on that, you might as well name it after the guy who put it on the map.
Exactly.
Yeah.
So Hubble was, one of the first goals of Hubble was to measure better the rate of the expansion of the universe. We expected that as we became better able to look at more distant galaxies, which is looking back at time and measuring the expansion rate at that time and comparing it to the expansion rate in the current epoch, that we would see that the expansion rate of the universe has been slowing down. That was the expectation because gravity basically is trying to pull things together and perhaps slow down this expansion. The surprise in recent years was that by comparing Hubble observations with also observations from good telescopes on the ground, and looking at the difference between the expansion rate in the distant universe, meaning far in the past, with the expansion rate in our current epoch, that the universe expansion rate has actually in recent epochs, meaning in recent billions of years, been getting faster. It's accelerating. It was first decelerating, and now it's accelerating. We don't know what's causing that. Hubble's a big player in this discovery. It's not the only player, but it's a big player. And so now this is a whole new enterprise in astrophysics, is trying to understand what is it that could be accelerating the expansion of the universe.
We're getting better with age. That's all. That's all.
All right. Tacking on 1 billion years, you're looking even better.
That's right. That's right. Look at that. All right, cool, man.
All right.
So let's go to Cameron Kessler from Facebook. Says, does Hubble have any sufficient technology to keep up with the needs of today's understanding of the universe? And will there ever be a telescope with a 360 panoramic view like Google Street Maps? It's a pretty cool.
That's the measure of the future of cosmic discovery.
Cosmic discovery
Yeah.
is, will we have a Google Cosmos Maps like Google Street Maps? I know the Mars rovers do this, their pictures, but would it make more sense to have this sort of thing instead of falling back on now this is throwing a little shade here, the excuse, we have to look in the right places, as they used to say in SETI. Ooh.
But I'm trying to understand the question. Is it,
in other words,
is it, let's look everywhere instead of in places we think we want to find something?
Exactly.
Because we might discover something we're not looking for otherwise.
Well, basically, he's saying like Google Maps. So it's just like, I really want to go to 359 Main Street, but what's that over there? Oh my God, that coffee shop looks pretty awesome.
Okay.
I'm going to go check it out.
All right.
So
This is a very good question. And we need both because we want to be able to see everything in the sky. And we have survey telescopes that are designed to do just that, to have big fields of view and to survey the entire sky, often for a particular reason. So right now, for example, we have the TESS satellite that's surveying the sky, but looking specifically for stars that may have planetary systems around them in our nearby neighborhood.
Is it fair to think of TESS as a follow-on to Kepler?
I think so, yeah.
And TESS, get me through that.
The Transiting Exoplanet Survey Satellite, I think. I'm going to have to remind myself. But anyway, the idea of TESS is to do just that, survey the sky.
TESS it. Transiting Evidence Survey Telescope, I think. TESS it.
And then there's a telescope being designed for the ground, the Large Synoptic Survey Telescope. The whole idea of this is to do the whole sky survey very frequently. So it's a good idea. However, when you're doing that, you're not getting the precision in small fields of view that you can get with a telescope like Hubble. So it depends on the purposes at large. If you really want a high angular resolution, precision, high sensitivity observation of something, that's a different goal than doing a whole sky survey. And we sort of need both of that. So the best way this works is if you're doing whole sky surveys, and then if you find something that you'd really like more detail about, then you hone in with some other telescope to do that. Hubble is really not good for these whole sky surveys. It's much better for pointing and getting much higher angular resolution. My favorite example of this is the Orion Nebula. I love the Orion region of the sky. It's a very famous constellation. I did my own doctoral research on star formation in this region of the sky.
Isn't the closest star-forming region to us?
It's the closest region of massive star formation, so stars bigger than our sun.
All right.
But they light up these massive stars. Once they form, they're so powerful, they ionize the surrounding gas, so you get these beautiful nebulae. So the Orion Nebula is famous. Hubble can peer into that Orion Nebula.
Jennifer was born in the Orion Nebula.
Maybe I was. It's possible.
She's the spirit energy of the Orion Nebula.
Possible I wasn't told, but maybe, you never know.
How would you know, right?
I'm told I was born in Arkansas, but
Listen, in this current climate, let's go with the Arkansas story.
Anyway, I love the Hubble image of the Orion Nebula because it does give you that great detail. You can see massive stars, you can see the colors, but you don't get the big field of view that you can get with other telescopes.
Gotcha.
Next.
All right, here we go. This is Holdwig at Thunder O Storm on Twitter, and he says, or she says, or they say, if I want to be correct.
This person says.
Thank you.
It's possible to get through this, Chuck.
It's just that once I start thinking about it, I'm like, well, that can't be right. Well, that's not right either. What am I doing? I don't know anything anymore. Help me, please. Okay, here we go. What are the projects that you think will be the most important for this current decade? So we're in the 20s now. What's going to happen between 20 and 30 that is the most
Would this be
important?
what Hubble would be able to contribute in this decade, or is that
They
more
don't
general?
They just say, what are the projects? I mean, of course, they're talking about telescopes, but they just say, what are the projects?
Well, that's a terrific question. And Hubble is poised to be a major player in these astrophysics discoveries in the coming decade. So one of them I've already mentioned is kind of getting a better grip on this idea that the universe is expanding at an accelerating rate. How's that? Why is that? And how is that working?
So who ordered that?
Exactly. And so telescopes like Hubble will be working in concert with other observatories. The Wide Field Infrared Space Telescope, or WFIRST, is a telescope idea that's being developed and right now that will be a large, again, one of these big fields of view that can kind of give us a better sense of how galaxies are distributed and how they've become distributed over time, and that's related to dark matter and dark energy.
Just remind me, wasn't WFIRST a retooled, decommissioned military telescope?
Right. We took a telescope that had another purpose, and now we're re-envisioning it to do this kind of study, big surveys of in the infrared,
which helped reduce the cost ultimately.
That was the idea. Although sometimes
that sounds like a no.
Retooling things has its own complications. But it is going to be a terrific telescope. I
When I
think
say military, I meant spy telescope.
the name
that's
of
what that means.
the name of the game, I think, for the coming decade is complementary cooperative work. Let me tell you, one of my favorites is that Hubble is being used in complement with probes that we're sending out to other planets in our solar system. And we get much more information this way than we would by just Hubble alone or just the probe alone. For example, the Juno probe that's at Jupiter right now is getting all kinds of information about Jupiter's magnetic field and gravitational field. And Hubble is back here orbiting the Earth, looking at Jupiter, and Hubble has the unique ability to see the ultraviolet light coming from the auroras, the magnetic poles of Jupiter, and those are dancing around relevant to what's happening with the magnetic fields around Jupiter that Juno is measuring in situ there. So this cooperative work gives us a lot better understanding of these magnetic fields and what's happening on Jupiter and even its moons than we could
So it's
alone.
it's not an after the fact conjoining of data.
No.
It's an in situ.
Yes,
That is
exactly.
beautiful. I love
really
that.
cool.
Right.
yeah.
We're doing things cooperatively with Hubble. Another example in just the recent past was when the New Horizons probe went past Pluto.
But Pluto goes unmentioned here. We don't.
Oh,
Pluto's not
well,
allowed.
Pluto is still there and it's doing fine, right? So, and in fact,
Just because you're not taking Pluto's calls, Neil, doesn't mean it still
okay.
doesn't
I'll
have
make an
a
exception.
phone.
I'll make an exception. Okay,
in
go
fact,
ahead.
Pluto is beautiful, and Hubble was used as New Horizons was on its way out there. Hubble was used to find other undiscovered moons around Pluto and to help New Horizons, help us chart a good course for New Horizons, and even to help New Horizons to know what objects to look at beyond Pluto. So these are things that I think are examples of how Hubble and other telescopes are going to be used cooperatively in the coming years to give us a lot more information than we could from any observatory alone.
Wasn't there also a mission? I have a memory where there was a probe to an asteroid where it dropped a projectile, which would then kick up asteroid dust.
And then collect.
With in a direction and an azimuth and an angle, so that was it Hubble that would then be able to see through the dust and get a spectrum?
Well, that was the idea. Yeah. So it kicked up dust. It was observed by quite a few
Oh,
telescopes.
it's quite a few telescopes.
And
okay.
I would have to, to look into the details of what was found. But I thought that was a really nifty idea.
So it's another example of
Right,
I'll do this and
the
then you do that.
collaboration,
Yeah,
yes.
yeah. Cosmic collaboration.
Yeah. By the way, what a brilliant idea.
Yeah,
To
yeah.
drop a projectile and kick up the dust and then look through it.
Look through it with
That's-
ground-based telescopes or space-based telescopes.
Yeah.
Yeah.
I got to say, you guys are really smart.
Thank you, Chuck.
Yeah. Just in case you hadn't, just in case no one's told you, wow, you guys are really smart, man. You NASA people, it's amazing what you do.
So we got to wind this segment.
Could I add one thing?
Go
I
ahead,
would be
go for it.
remiss, Chuck, if I did not bring in a huge topic of interest for the coming decade, which is the whole topic of exoplanets.
Oh.
And this is where telescopes will be working very cooperatively. We didn't even know back when I was in graduate school if there were planets orbiting other stars other than our sun. Now, because of telescopes on the ground and telescopes like Kepler in space, we know of thousands of star systems that have planets. And so now we can presume that most stars have at least one planet. Hubble will be being used in the coming decade to do more analysis of the atmospheres of these exoplanets, complementing work from telescopes like TESS, that's looking around for nearby systems that have planets, and
That finds the
future.
system. Then there's the handoff to Hubble to analyze the system.
Yes. Also, the James Webb Space Telescope that will be launched in 2021 will be looking at exoplanetary systems in the infrared part of the spectrum, and that will complement Hubble's observations of these exoplanetary systems. Hubble can see a little in the infrared, but mostly in visible and ultraviolet light. And so we'll be getting this wonderful suite of information by using Hubble in complement with other telescopes about the nature of exoplanets.
Excellent.
Just think about it. First, you got to know that it exists.
Right.
Then you have that catalog, and now you go in with a whole other layer of questions.
Right.
Yes.
And then that might open other questions you didn't even know to ask at the previous round. So
Well,
you
we
could take
wanted-
this.
yeah.
Now you're saying, well, I want to look at the atmosphere of the planet. You're not happy just knowing there's a planet there.
Right, exactly.
When there was a day when that was a banner headline, there's a planet there.
Right, exactly.
Right. So what a luxury to even have that ability to make that measurement.
Exactly.
We got to take a break.
Okay.
When we come back, we'll finish out our 30th anniversary Cosmic Queries on Star Talk.
Hey guys, it's time for a Patreon shout out to the following Patreon patrons: Alejandra Salinas and Adam Cook. Thank you so much. Without you, we couldn't make this trek across the cosmos. And for those of you listening who would like your own Patreon shout out, go to patreon.com/StarTalkRadio and support us.
We're back with Jennifer Wiseman from the Goddard Space Flight Center in
Greenbelt, Maryland.
Greenbelt, Maryland, right outside of D.C. I've been there. It's a huge campus. I mean, it's got engineers and scientists working
Right.
in harmony.
Nice.
Absolutely.
That's as
Jets and sharks living together.
Jets and sharks.
Look at that.
Boy,
Boy.
crazy boy. It's cool. I just saw West Side Story on Broadway.
Did you?
Yeah, the
new
revival.
one?
Yeah, the new
Okay.
one. Yeah. So, Chuck, we got more questions.
Yes, we
Yeah.
do. Here we go. This is from Lewis. I'm sorry. The Force Choked Podcast. Okay, I don't know what that is, but from Instagram. Hey, Neil and Jennifer, what is the plan for Hubble as its final photo, and when will that be? What's the lifespan of Hubble? How long?
Yeah.
How long can this go on?
Well, that's a great question. You know, Hubble was launched back in 1990 from the space shuttle, and it was designed to be continually replenished with the space shuttle missions, which we did for a lot longer than we originally expected. So we're not servicing it anymore because the space shuttle program is over. We're now building a new future spacecraft.
Space Force, yeah.
Exactly. So we've got what we've got with Hubble, but Hubble's working very well. The last astronaut servicing mission we did back in 2009 was very successful, and they've left the telescope. The astronauts went up and put in some new science instruments and repaired some other instruments and some other equipment on the telescope. It's a satellite orbiting the Earth, and Hubble is doing very well right now.
Okay.
Did they leave
And-
graffiti on it because they're the last ones there?
so
Like
cool.
Susie was here.
If they did, they didn't tell me.
Yeah, no,
Yes,
right.
right. But
Jennifer took that question.
Yeah,
a little personally.
I know.
Did you see her get a little disturbed?
It was really
She
a
was like,
joke
and-
question.
It was a joke, and she was like, "And if they did not tell me."
Now
And
that-
I swear, I will give them such a look.
I want you to know out there that I did not have that look at all. I have
We
nothing.
have you on camera,
We
Jennifer.
we got
nothing-
you.
Too late. We're busted.
I will tell you that one of the astronauts, John Grunsfeld, who is an astronomer himself, brought with him
And a friend of Star Talk. He's been on several
Awesome.
times. Yeah.
He brought with him a model of Galileo's telescope. And so up there on the space shuttle during the last servicing mission, we had this marvelous juxtaposition of this model of Galileo's telescope from 400 years
The
ago.
first telescope. Yeah.
And out the window of the cockpit of the shuttle, you could see the Hubble Space Telescope. And so it was just a wonderful visual of how the progress of engineering and curiosity and optics all work together to give us a
money.
brand new understanding
Money.
of the universe. Exactly.
Yeah.
You can be as curious as all get out.
Oh, well.
But if nobody's paying for
Nobody's
your
paying for
ideas,
it, yep.
you just go
Right.
back to the
You
cave.
Just got some great ideas.
Well, but you have to have the ideas to get people to donate the money. So
Yeah.
it's all works together.
All right.
Well, speaking of that, let's
But
stay right.
I didn't quite
Oh,
answer
go
your
ahead.
question. So
Finish.
Hubble is working very well, and so we don't really have an end date of Hubble in mind. The kind of stated NASA position now is as long as Hubble is being scientifically productive, we'll keep operating it. And it looks like, just from looking at the health of the gyroscopes and the batteries and the science instruments, that we'll be able to get good science from Hubble for probably through the end of this decade and maybe even beyond.
Not bad.
And that's great because we want it to be operating while other telescopes are also operating with complementary capabilities.
Right.
The James Webb Space Telescope should launch in 2021, and it will be a fabulous space telescope tuned into infrared wavelengths of light.
Right.
And so in the infrared, you can peer at galaxies that are very distant in space and time. Their light is getting redshifted as it travels through expanding space to get to us. And Hubble can't see that far into the infrared spectrum of light. So Hubble can see very distant galaxies, but the Webb will see galaxies even a little bit farther back in space and time.
We're going to emphasize something you just said, because it's remarkable to me.
Yeah.
All right. So we are seeing infrared light from galaxies in the early universe who, in the early universe, were emitting visible light.
Right.
Okay.
Or even ultraviolet.
Or even ultraviolet.
Right.
And that
So it's
all got
cooled down.
redshifted
Exactly.
Right.
over to the infrared part that the James Webb Telescope is tuned to see.
That's
Nice.
Right. So we're folding in that
Exactly.
knowledge of the universe
Right.
to nab those galaxies right when they're being born.
Right.
I like to put it this way: the universe we think, at least the universe that we know and love, started about 13.8 billion years ago.
Okay.
And Hubble is seeing all the way back right now to baby galaxies from within that first 0.8 of the 13.8 billion year history of the universe. And the Webb will see even closer to the beginning of the universe within a few 100 million years of the beginning of the universe.
That's
you can
amazing.
see basically
The cradle
infant,
of creation.
That
infant
is.
galaxies
That's
with
almost
a
like
little
seeing
gas
the
and
universe
stars.
when it's crowning. That's amazing.
Well,
It's amazing. It's just like, oh my God, the baby is coming in its second now.
this is a little too graphic, but it's not. Let's think a little later. Let's think toddler stage.
Okay, all right,
toddler,
all
right.
toddler. All right.
Because what these telescopes are seeing are after the first gas formed from the first atoms, which formed from the first subatomic particles, you finally get enough gas to form stars. And these stars and gas coalitions, if you will, are what we call the first proto-galaxies.
Right.
And that's as far back. That's what the Webb telescope will be seeing. And over time, these little baby galaxies began to merge together and form bigger galaxies.
Right.
And these grew over cosmic time into the galaxies we know and love today, like our own Milky Way, which is the product of several mergers over time.
Right.
Yeah.
And has there been any recent collisions that we have seen of galaxies?
Well, of course,
that we
it
have?
takes a long
I
time for
know.
galaxies to actually merge. But Hubble, actually, that's one of the wonderful discoveries of the Hubble Space Telescope is that merging is common and was more common in the early universe. So with Hubble, we've looked out into distant space, looking back in time, and we've seen quite a few cases where galaxies are either in the process of merging or they've already merged. And that merging process creates distortions in the shapes of these galaxies because of the tidal pulls and the gravitational pulls. And it's quite interesting. We believe that our own Milky Way is set to merge with our nearest neighbor, grand spiral, the Andromeda.
Yeah.
And we're on a head-on collision course. That's something Hubble helped us find a
Thanks
few
a
years
lot,
ago.
Hubble. Thanks.
So the night sky was going to look a lot
Blame the
different
telescope.
in a few billion years.
Right.
But it won't be for quite a long time.
Quite some time.
Billions of years.
All right, staying
Yes,
right there
right.
with the with the future here. Team Foresight Observatory wants to know this. Hi, Neil, Jennifer, Chuck. Would it be possible if NASA ends funding for Hubble or it comes to its regular end, someone like Elon Musk could buy the rights to the scope and send his own repair missions, thereby now owning the telescope?
Good question.
Because we are seeing that, right? We are seeing we are seeing the commercialization of space. We're seeing more collaboration between the public and private sector with respect to missions to space. So, what's the feasibility of this?
Yeah.
Is it for sale?
Yeah.
It is not for sale.
Yet? If you're a billionaire, say everything's for sale.
Exactly.
The current plan is we'll operate Hubble for as many years as it is scientifically productive, and then when it's not no longer providing good science, it will cease to function. Eventually, we'll need to either push the satellite itself either to a higher orbit, we call it a parking orbit, or else help direct it safely into the ocean.
Pacific Ocean.
Yeah, well, I don't know exactly where. But As
toilet
for
bowl
private
of-
company involvement, we don't have any official plans for that right now. But let me tell you, there's a lot of energetic discussions out there. So, stay tuned for
I
coming years.
love
Yes,
that
right.
idea. If it's Hubble's, we're going to plunk Hubble in the Pacific,
Right.
someone can buy it. I think
Let somebody buy it, right? And continue to receive
But
information.
let me add this though. Astronomers think about this very hard all the time. What's the best kind of facility to have to do the kinds of astrophysics we want to do? And there comes a point, such as came the point with my own car recently, where you have to decide, is it worth it to put a lot of money into continuing to refurbish something that's decades old?
As they call it, nickel and diming. you.
Exactly. Or is it better to build something fresh using newer technology? So, Hubble's
good
not in
point.
that situation. We hope Hubble will be operating for much of the next decade and beyond. But at some point, the decision will need to be made as to whether the kinds of capabilities that Hubble does could be better done with a new telescope. And in fact, there's some wonderful concepts being developed right now for Hubble follow-ons.
Fantastic.
all
All
right.
right. Neil told
Chuck,
me
yeah,
to
wait,
make this
going
the
fast.
last
Okay.
one, right? For you, because this is a personal question just for you, Doctor. And this is from Brett Shara. And Brett Shara from Instagram says, what is your favorite Hubble discovery? By the way, I'm a huge fan. Thanks for all that you do. So this is somebody who follows you and wants to
Awesome.
know, what is your favorite Hubble anything?
I'll slip into my favorite Hubble discovery. It doesn't sound flashy, but is actually looking at things like the ultra deep field and finding out that galaxies themselves change in amazing ways over billions of years. And Hubble being the time machine that it is, we can actually map out by looking at distant galaxies and comparing them to nearby ones how they've changed.
so. This ultra deep
Yes.
field is even deeper than the original concept
Yes,
of deep field.
that's right, that's
once they got the deep field swagger,
Right.
it's like, let's do this again.
Right.
Yeah, exactly.
Okay.
Let's get a deeper field.
And then one image that I just love. It's nothing special, if you will, but it's just a beautiful galaxy. It doesn't have a beautiful name. NGC 1309. I just think is a gorgeous spiral. So those of you listening to this, go out and Google NGC 1309 Hubble, and you'll see a beautiful spiral with some interesting galaxies in the background.
If you call it
And
on
it's
your
my
phone,
favorite.
NGC 1409, it'll answer.
Beautiful nebulae. I'm holding one now. NGC.
You're holding a picture.
I'm
of
holding
one.
a picture of one.
Yes, actually, it was on a cat's collar, and she now has
there it is.
NGC 3603, NGC 3603 is a
So
beautiful.
if someone Googles that, they'll go to this image online.
Yeah, if you use Hubble in the name, you'll see this cluster of newly formed stars surrounded by beautiful ionized gas, a kind of purplish nebula. And to me, this just shows great beauty in the universe and how our telescopes are enabling us to see these kinds of beautiful active regions that we haven't been able to see in such detail before in human history. And this inspires all kinds of things, even beyond science, art, science, philosophy. All kinds of things are inspired by the observations we can do with Hubble and other telescopes today, and I'm grateful for that. So thank you for your comments.
Yeah, I just looked up NGC 1309,
Yes.
and Apple owes you guys some money.
Why?
Because this is what comes up on my computer.
That's the Hubble image, and
That's the Pinwheel Galaxy.
no, it's not. They don't owe any money because all of our images are freely available to anyone, and so
You done already
yeah.
paid for it.
They pay. We pay our tax dollars.
Tax money paid for
Oh, in that case, Apple owes me some money.
That's right.
You can fight that out with them. Yes. Okay.
We got to land this plane.
All right.
So, Jennifer, you have any just concluding reflective thoughts beyond what you have, the reflective thoughts you've already shared?
I think that the Hubble Space Telescope has shown how we can use, as humanity, we can use technology to do something that not only enhances our scientific understanding of nature but also gives us a sense of unity. There are people all over the world from every nation that are excited about the Hubble Space Telescope and what we're seeing. And it gives us, I hope, a sense of unity as citizens of Earth, that we're part of a magnificent universe, an inspiring universe, something to look up at and be inspired by, and to keep our sights, our spirits high. I think astronomy inspires all kinds of Positive. And
Except for when that asteroid
deeper
is coming.
deeper thoughts of beauty and philosophy and theology and art and music, and all of these things are part of what it means to be human. So keep looking up, I'd say.
Somebody just
Damn,
can't,
I got
you can't end the
nothing.
show now. You got to let her end the show now.
I can't.
You got to let her end the show now, Neil.
What?
You got nothing. You got nothing, bro.
You got nothing.
You got nothing, Doc.
Jennifer, you just took us out. That was Jennifer Wiseman ending Star Talk for me. All right, we'll catch you on the next round.